Our third objective says to use the molar mass to convert between mass and moles of a substance. The term molar mass allows us to weigh and exchange into the mole. Objective 3 will deal entirely with this road. Given a gram, we'll use molar mass to head into the mole, or given a mole, we'll head out to the scale in grams. So objective 3, entirely one-step problems, either grams into mole or moles back to grams. The conversion factor we use is the term molar mass. It's what we just practiced, adding the weights off the chart. So our first question of objective 3, how many grams are in 6.9 moles of trinitrogen dioxide? We'll write the number 6.9. The unit is the mole, and the label trinitrogen, N3, dioxide, O2. My conversion factor must cancel the mole, so the mole goes on the bottom, and the molar mass gets placed on the top. Again, visually, if I'm at the mole and heading out, follow the arrow out. Following the arrow out to the scale, I see the molar mass is placed on top, the mass of 1 mole of a compound. So we'll add together nitrogen, 3 of them, and oxygen, there's 2 of them. Ready? Finding nitrogen on your periodic table, I see nitrogen is 14, and oxygen's right next door, it is 16. Alrighty, so finding those weights, 14 times 3 for the nitrogen, plus 16 times 2 for the oxygen. We get a formula weight of 74. Moles times molar mass converts it into a gram. So we'll take our 6.9 moles, multiply that by 74 grams, and we get a mass of 510.6 grams of N3O2. Our second question, find the number of moles in 103 grams of iron 3 chloride. Let's start by writing our number, 103. The unit right after that is grams, and the label, iron 3 chloride. Iron, Fe, with its Roman numeral 3, tells me it's going to carry a positive 3 charge. We're going to hook that to chloride, who carries a negative 1 charge. So a plus 3 and a negative 1. FeCl3. We'll need a conversion to cancel grams and head into the mole. If I want grams to cancel, it needs to be placed on the bottom with the unit mole up on top. Oops, sorry, FeCl3. Not very neat, I apologize. Again, visually, I'm at the scale heading in. I'm at the grams heading in. See how the molar mass is now on the bottom. So we need to do a little side work. We got to add some formula weights together. Fe with its atomic weight, 55.8, and chlorine will use 35.5. We have 3 of those. 55.8 on the iron plus 35.5 times 3 on the chlorine gets me a formula weight of 162.3. This is a divide by question. Starting with the number on top, 103, divide by the molar mass of 162.3, and we find 0.63 moles of FeCl3. Number, unit, label, every step, every way. One more. How many moles are in 78.5 grams of ammonium carbonate? The number, 78.5. The unit is a gram. And ammonium carbonate. Ammonium is our positive polyatomic ion, NH4 plus 1. We're going to hook it to carbonate, CO3 minus 2. So a +1 with a -2, when we crisscross, we'll find ammonium, NH4 taken twice, carbonate, CO3. We'll convert using the molar mass. The mass of 1 mole of ammonium carbonate. So we'll get to do some legwork here and add some weights off the chart. Nitrogen with its atomic weight of 14, but there's 2 of them, plus hydrogen with its atomic weight of 1, and I'm counting 8 of those. Distribute means to multiply through. Plus the carbon with its atomic weight of 12, and there's just 1 of those. Plus the oxygen, who weighs 16, and I count 3 of those in the formula. Grand total is 96 grams of ammonium carbonate. The mass of 1 mole, the formula weight here was determined as 96 grams. Again, a divide by question, as grams will cancel and head into the mole. 78.5 grams divided by our formula weight of 96 cancels the grams and brings us to the mole. I find 0.82 moles, and my label here, ammonium carbonate. Alrighty, 3 points apiece for a total of 9 when we get ready to receive our A+.